Okay, if you're following along in the sequence, we're trying to find the position of this boat right here from us. Unfortunately, I tried working this out and I keep breaking the 10-minute marker. So I'm going to do this and hopefully you could follow along. Um, so what I need is to find vector c. And remember, this red vector right here is my velocity vector. It tells me the speed of my boat, which I computed to be 11.2, and the direction it is going. This red line right here is what we call a directional vector. The boat will travel in this direction. It doesn't tell me anything about speed, only the velocity vector right here tells me the speed. The directional vector just tells me that the boat is traveling as such. Now what I would need to find, I need to find the position of this boat from where I'm at. Not the coordinate of the boat, the position of the boat for me. Now, if the boat happens to be here, then the position of the boat is there. And its position for me is given by so many units x, so many units y. That component vector is what we call xy from me. Now, if taking everything back to where the original equation was right here. I need to find vector c. Remember, vector c was equal to vector a, right here, vector a plus vector b, which is right there. So c is equal to vector a plus vector b. The reason I have time right here is because the boat is moving. In 1 hour it's right there, in 2 hours it's right here, wrong point, 2 hours it's right there. So that is the equation. Now in order for me to compute something, I need points. So what I do is this. The lighthouse, I'll call point O. The initial position of the boat, I'll call point A, and the direction the boat is going, I'll call point R. So the blue vector, which is known as vector A, is vector OA, which I have right there, vector OA. Plus vector B goes from A to R, and here I have vector AR. And I forgot to put a little vector symbol above it. And the vector I am trying to compute is vector C right here, which is from O to R. So vector C is OR. If I'm talking too fast, please hit the pause button. I need to break the 10-minute marker. Now, what does this mean? It's very simple. The position of me to the position where I'm at, to the position I'm looking for, is OR. The initial position of the object, again, it's from me to where the object is at, is OR, plus the direction the object is traveling, AR. Now the nice thing is the direction the object is traveling is called the velocity vector. It's known as the velocity. And in the problem I gave you, I told you that the velocity was 10 negative 5. So I really don't have to compute this red vector. I just use the vector they gave me, 10 negative 5. Now, if you look at the picture, the original diagram, here's the lighthouse, and here is O, here is A, here is R. Our position, according to this grid, is negative 5, negative 20. According to this grid, the position of the boat is negative 25, 5. And the direction the boat is going, I don't care, because right here I have the directional vector. No need to compute it. Moving along, let me cover this up so you could follow along a little bit easier. I have all the information I need. Me at O, here's my vector. The initial position, A. The velocity, 10 negative 5. Need to find these values. Well, this is with T. So, vector OA is equal to, and remember how I find a component form, it is x2 minus x1, y2 minus y1. There's that one thing I told you to be careful about, because sometimes you want to compute the y2 minus y1 over x2 minus x1. I plug in my points. Here I have x2, y2, x1, and y1. Come over here, and I get that vector, negative 20, 35. Again, hit the pause button if I'm talking too fast. Oh, I lost my vector here. Let's see, this goes down. Now, AR is my velocity vector. I don't have to compute it because the boat is traveling at 10, negative 5. When I take this value and this value and plug them into that equation, I come up with the position vector OR is equal to negative 20 over 35 plus 10, negative 5 t. Now, if t is 0, that means that this vector right here is going to cancel out. 0 times this is 0, and that just leaves me with OR is equal to negative 20 over 35. That means that at the initial time 0, the boat was 20 kilometers west of me, 35 kilometers north of me, which is a little bit confusing because the initial point, and let me take you back to our picture, the initial point was negative 25.5. Now, if you look over here, we're saying that we are negative 20 kilometers west, 35 kilometers north. Now, if you look at this right here, this vector is actually, let's see, 5, 10, 15, 20. So you see it's 25 kilometers west of me and 5, 10, 15, 20, 25, 30, 35 kilometers north of me. That is the position of the boat from me. What I effectively did was, I still have some time, what I effectively did was I just recomputed everything to say, you know what, I don't like dealing with a lot of numbers. It'd be easier if I were the origin. If I am the origin, then I am at 0, 0. And now you could see that the initial vector that I found was negative 20, 35. So this vector right here, the position of the boat from me is negative 20, 5, 10, 15, 20, 35 north. 5, 10, 15, 20, 25, 30, 35. Okay, I changed the lines to blue so you could see them better. Now what I'll be doing in the next video is computing other positions of the boat, whether it's here, 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 or here via the time. Sorry I couldn't compute that for you, but as you can see, just explaining it took 8 minutes, about 9 minutes. So please watch the next video.